Good morning, this is Kasturi De. Today I'm going to discuss the electricity and magnetism chapter question answer series. I was continuing with the short and long questions. Okay, so I'll continue with them. The first one is, how will you test whether a given rod is made of iron or not? If we bring a magnet near the given rod and if the rod is attracted by the magnet, then it will be made of iron, else not. Okay, if it is not attracted by the magnet, then it is not of iron. Then if you are given two similar bars, one is a magnet and the other is of soft iron, how will you distinguish and identify them? Now for this, let us place the bar A. We identify as bar A and bar B. One is of soft iron. Let's say, bar A and bar B. One is of soft iron, the other is of other material. That is magnet. One is of soft iron and that is of magnet. Now place the bar A on the table. Then we touch the one end of the bar B to the bar A. First at one end, then at the other end. Finally at the middle. Okay, first we touch. If we take the bar magnet on the bar A, we keep it, and then we with the bar B, we first come to this end, then second this end, and then to the middle. Okay. Now if the bar B sticks to the bar A at both the ends as well as at the middle of the bar A, then the bar B will be a soft iron bar. Now let us repeat the above process by placing the bar B on the table and touching the bar A at one end and then at the other end and finally in the middle. We will find that the bar A will be stuck to the ends of the bar B, but it will not be stuck at the middle of the bar B. So the bar B is a magnet. Okay. Now if we are given a magnet, how will you use it to find north and south direction at a place? Excuse me. If that magnet is suspended with a silk thread, with the magnet which you are given, let us suspend the magnet with a silk thread on a wooden stand. Now, if the magnet swings for some time and comes to rest in a particular direction, and that direction will be north-south direction, the end of the magnet which points towards the north, that is the north-seeking pole or the north pole, and the end of the magnet which points towards the south, that is the south-seeking pole or the south pole. Okay. Next is, describe a simple experiment to illustrate the like poles of two magnets repel each other while unlike poles attract each other. For this, two bar magnets A and B are taken. One magnet A is suspended with a silk thread from a support so that it is free to swing. Okay. Now the bar magnet will come to rest in a north-south direction. I told you when we suspend a magnet with a silk thread from a support, then it will swing for some time and then it will come to rest in a particular direction, and that is the north-south direction. The north pole of the magnet A is in the north direction and its south pole is in the south direction. Then the north of the magnet B is brought near the north pole of the magnet A without touching it. We observe that two poles repel each other. And if we bring the south pole of the magnet B near the north pole of the magnet A without touching, we see there is some attracting force, and that shows that two poles attract each other. The unlike poles attract each other. So this shows that when two magnets are taken, like poles repel each other and unlike poles attract each other. Okay. Now next week question, poles exist in pairs. Comment on this statement. So if a bar magnet is broken at the middle into two parts, each part is found to be a magnet. Okay, each part has the property to attract small iron pieces. and each part rests in the north-south direction when they are suspended when they are suspended by a silk thread on a swing. It will swing for some time freely, and then it will come to rest in a north-south direction, So each pole, each magnet piece will behave like an independent magnet. They will create new poles as formed at the broken ends. Okay. If these pieces are broken again and again, each part will still be found, behave like a complete magnet. Each part contains both the poles, and therefore the two poles of a magnet exist in pairs. It is not possible to separate the two poles of the magnet. Now, what is a magnetic compass? State its use. So, magnetic compass is a small magnetic needle pivoted at the center of a small brass box. There is a brass box. Okay, there's a round brass box in which there is a needle inside, and on this there is the needle which is pivoted on this. There's a pin, rather a fulcrum or pin, on which the needle is placed, magnetic needle is placed. Okay, and there's a glass top covering the box. Okay, and this needle is free to rotate. One end of the needle is painted red. One is painted red. This is pointed, which will point towards the north, indicating the north pole. It is used to point towards the north direction of the earth. Okay. Next is this is done by keeping the magnetic compass on a table, and the needle rests in the north-south direction with the red end pointing towards the north. Okay. Now explain the meaning of the term magnetic field. If a bar magnet is placed on the table near a magnetic compass, it is observed that the magnetic needle of a compass swings and then rests in a direction other than north-south. If the magnetic compass is placed at different points around the bar magnet, it is observed the direction in which the magnetic needle of compass rests changes. This shows that the space around the bar magnet has a property to influence the magnetic needle of the compass. Therefore, the space around the bar magnet in which the magnetic compass gets influenced is its magnetic field. So, what happens that when we keep a bar magnet, the field around the bar magnet is the magnetic field. Okay, there's a field around the bar magnet. And if in that field we keep a magnetic compass, we'll see that it will swing for some time and it will rest in a direction in which it is not according, it will rest in a direction which is other than the north-south direction of the earth. Okay, so actual north-south direction. Why? Because it has been deflected or it is influenced by the bar magnetic field, the field of the bar magnet. Okay, so this is the magnetic field or the space around the magnetic field in which the magnetic compass has get influenced is called the magnetic field. Now, what is the electromagnet? Electromagnet are temporary magnets which are made of soft iron by electrical method. When electricity is passing through a soft iron core, it produces a magnetic field or it makes the soft iron magnetized, which is known as electromagnet or temporary magnet. Okay, it is a temporary magnet which is known as electromagnet. Now, draw a label diagram to make a soft iron bar as an electromagnet. Describes its step in the procedure. Now, we take a soft iron bar and we wound round a wire around the bar. This is a PQ soft iron bar. We wound round a wire around it and connect it with the cell. Okay, this is the positive terminal, this is the negative terminal, and with a switch. When we switch on the device, then current will start flowing from the positive terminal and will go round this soft iron bar. Okay, and it will create a magnetic field around this soft iron bar, because it will get magnetized. Okay, so what will be the steps? The first step will be that if we have to take a soft iron bar PQ and wound round an insulated copper wire around the bar. Okay, then we have to connect a cell or a battery and a switch K in the series between the ends of the coil. When the K is closed or the switch is on, current passes through the winding of the coil and the bar magnet becomes the soft iron bar becomes a magnet. Now, when the K is open or the switch is off, current stops flowing in the coil and the bar loses its magnetism. Okay. Therefore, the bar behaves like an electromagnet, and when current passes through the coil. Okay. Next is, you are given a U-shaped soft iron piece, insulated copper wire and a battery. Draw a circuit diagram to make a horseshoe magnet. So see, this is a horseshoe shaped U-shaped soft iron piece, which is wound round by a insulated copper wire. Okay, and a battery is given. This is the positive terminals, these are the negative terminals, and the switch is there. When we switch on the battery, current start flowing from this positive terminal, and current flows through this arms of the U-shaped soft iron and makes it magnetized. Okay. Then state 2 ways on which the strength of the magnetic field of an electromagnet can be increased. By increasing the number of turns of the coil. If we increase the number of turns of the coil, then we can increase the magnetic field of the electromagnet, or by increasing the strength of the current passing through the coil. If we increase the flow of current, how much the current is flowing, if we increase that strength, then only we can also increase the strength of the electromagnet. Okay, so let me stop here. I'll continue with the rest of the question answers in the next video. Please go through this. If you have any doubt, please do write in the comment box, and if you you can also give some suggestions how to improve my videos so that it can help you better. And if you like the video, press the like button so that I can produce you some more interesting videos. And if you are a new viewer to my channel or not subscribed yet, please do subscribe to get the notification of my next video. Thank you.